Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aida Shamira binti Muhammad Afia, and now I would like to continue this presentation with our first case study, which is proposed construction and completion of 35 unit shop office, including 29 unit shop office of 2-story buildings, 6 unit shop office of 3-story building, and 1 unit TMB substation. This case study is located at Lot PTO 14426, Bandar Universiti Paguh Mukim Jorak Daerah Muar Johor Darul Ta'zim. And the status for this case study is completed project, which start on 19 May 2015 and completed on 14 November 2015, which they took 78 weeks to complete this project. So now let's move to the parties involved in this case study. First, project participant, which is employer, main contractor, architecture, structure engineer, mechanical and electrical engineer, QS and infrastructure engineer. They are also had a subcontractor involved in this project. The type of pipe used in this project is reinforced concrete pipe. In this project, they use a few different dimensions of concrete pipe, such as 200 mm, 250 mm, 300 mm, 350 mm, and 400 mm. For smaller building, a conventional slab foundation could be enough, but for the 35 unit shop office, a variety of consideration probably lead to the selection of reinforced concrete pipe. This concrete pipe and steel reinforcement work together to successfully withstand horizontal force and maintain the stability of the structure. The strength, adaptability, and longevity of reinforced concrete pipe make them a great choice for sustaining the 35 unit shop office. So this is the method of construction for the reinforced concrete pipe. We will move to the testing and inspection procedures used to ensure the integrity of the reinforced concrete pipe. There are 4 types of testing, which is ultrasonic testing, low strength impact integrity testing, static load testing, and lastly dynamic load testing. Lastly, I would like to present about the effectiveness of the reinforced concrete pipe in supporting the shop office. Firstly, high load capacity. Their capacity to support hard weight is their main benefits. Secondly, versatility in soil. The capacity of soil to adjust to different soil conditions is another advantage. The construction location may have loose or unstable soil according to soil investigation. And lastly, resistant to lateral load. The load carrying capacity of a pipe is the maximum load it can support without failure or excessive settlement. So I think that's all from me, and thank you.
This is problems of reinforced concrete pipes involved during the construction. First is unstable soil condition, particularly because of the clay soil. These soil types put the structural integrity of the pipes at risk due to their propensity for excessive getting and lateral displacement. Second is noise and vibration produced by pipe driving, which had an impact on neighboring residential and commercial district. Piling construction noisy and perhaps cause structural damage to existing buildings. This was especially troubling. And lastly is quality control of piling, cause misalignment during driving, make pile not vertically, and improper driving, plus the piling cannot reach required depth. The solution for the problem, first is soil improvement strategies was used by engineers to address the problem of unstable soil. To minimize future settlement, the soft clays were first preloaded with surcharge and then pipe driven. They stabilized through the application of deep soil mixing, DSM, which increased their strength and decreased their compressibility. Second, for noise and vibration of piling, the project used vibro piling technique, which used vibrating hammers rather than standard impact hammers to reduce noise and vibration problems. Vibro piling is suited for urban settings since it produces less noise and less vibration in the ground. Lastly, for the quality of piling construction, they establish curing rules, continuously checking the positioning of reinforcement and closely monitoring the proportion of the concrete mix. Non-destructive testing technique like pile integrity test and ultrasonic pulse velocity were also used to check for interior defects and make sure the piles were structurally sound. For recommendation, we recommend during soil investigation to do high-tech geotechnical investigation like as soil sample and borehole drilling can offer the precise data required for the best pile design. We think that using real-time monitoring system during pile driving can assist in quickly identifying and guaranteeing that piles are installed accurately and effectively. Second is, we recommend using high-quality machinery that has less noise and vibration, and the construction must be constructed during working hours only so that the processes of constructing the reinforced concrete pile does not disturb any neighborhood around the site location. And lastly, we think that the person in charge of supervising during the construction of the piling must take note of the quality of the piling itself before the work starts. The engineer should do multiple checking. The type of piling, size, and also concrete mixing is daily with the specification and the drawing.
My name is Iskandar binti Muhammad Saifullah. I will continue the presentation for the second case study. We choose LHDN and office building in Pulau Pinang for IJM construction Sdn Bhd. LHDN and office is a completed project in Jetown Notus District, Pulau Pinang. This project was complete 36 months starting 1 January 2021 until 31 December 2023. So this is the parties involved in LHDN and office project. The client for this project is Lembaga Hasil Dalam Negeri Malaysia. IJM Construction Sdn Bhd was appointed as design and work contractor, while the quantity surveyor is the United QS Consultancy Sdn Bhd, and Lincoln Piling and Engineering Sdn Bhd was appointed as subcontractor for piling work. Next is the type, length and diameter of pile used in LHDN and office project. As you can see in the picture, this project used 500 mm diameter pre-stressed precast concrete spam. There are three types of length used, which are 6, 9 and 12 meters. It is either suited for use in 20-story office building where the loads from the structure must be effectively transported to the bottom. I will show the video clip for the method of installation used for the spam piles. There are two pile tests used to ensure the integrity of the spam pile. First is dynamic pile testing, also known as PDA testing. It is a method used to evaluate the capacity and integrity of the spam pile. This test allows for multiple tests in short period. The second is the pile integrity test, which is a non-destructive method used to assess the condition and quality of spam pile. It can detect variation that indicate potential defects such as crack or voids. Next, for the effectiveness of the spam pile in supporting the LHDN office project. The first is large capacity to bear the loads. A strong foundation is needed for the 20-story LHDN office building in order to sustain heavy load such as building weights, occupants, and other dynamic loads. High-strength pre-stressed concrete gives spam piles a substantial load-bearing capacity. The second is longevity and durability. Coastal regions such as Pulau Pinang are more likely to experience corrosion due to the elevated salt concentrations in the soil and groundwater. Because spam piles are made using centrifugal manufacturing process and dense, it has a strong resilience to corrosions and low permeability. And the last is minimize disturbance. It is required when doing construction in urban and developed area. The hydraulic injection method utilized reinforced pampas produce less vibrations and noise compared to the drop hammers or diesel.
Next is the problem involved in the case study. The first one is heavy rain. Malaysia is located at a tropical region, which means that we receive uncertain weather, including raining. Raining is indeed disrupted the work, and because of it, the construction is temporarily halted until the weather improves. Next is pile head broken. Pile head can be broken due to various reasons such as metal defects, stresses, improper handling, and more. Third is broken piling machine. During the construction, the machine stopped moving. The worker had a quick check and the machine was broken down. Fourth is welding cable broke. The problem appeared during the day around afternoon when the worker initially started the weld. The welding cable suddenly stopped. So this is the solution for the problem. Number one is heavy rain, planning and scheduling, referring to the Jabatan Meteorologi Malaysia. Working area covered with coverings to prevent water entering the area. Number two, pile head broken. Supervise the condition and determine the severity. Temporary support was installed to avoid collapses. Number three, broken piling machine. The operator reported to the site supervisor for immediate checking. Contact a specialist to repair the machine. And the lastly is welding cable broke. Contact a specialist for checking damages. Decided to replace the cable due to safety reason. The last one will be recommendation. Number one, heavy rain. We recommend using software that alerts if there is a changes in our weather, help in decision making and planning the work. Number two, pile head broken. Keep monitoring the work in terms of connection of pile head and structures. Added more reinforcement for strength might help the problem. Number three, broken piling machine. Having a backup machine in case unwanted event happen. Regular checking before commencing with the work. Fourth, welding cable broke. Prepare additional cable as a backup for a quick replacement. Proper maintenance and checks welding machines before work.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ilafifa binti Ibrahim. I will continue the presentation for comparison case study A and B. This comparison shows that the case study A and B are preferred on piling, but for our group suggests that selecting project B for better strength while choosing project A piling for a cheap and normal building. The similarities for both case study is between material composition and load bearing function. For the differences for both case study is the material use and load bearing capacity. The cost analysis project A piling is RM 1 million, but it a lower cost because of a simple manufacturing and less specialist labor. But for a lower cost, but for more construction waste. Project B piling is a RM 3 million, higher cost because of complex manufacturing process and higher cost but less waste construction material. Continue comparison case study A and B. Project B and Project A have a different advantage in terms of type, material and condition. For comparison effectiveness, Project A is not effectiveness because of use reinforced concrete pile, which are more standard construction project. Project A are not effectiveness because of lowest initial cost due to simple manufacturing and material. But for Project B, effectiveness because of use pre-stressed concrete span pile, which high load bearing compressive, and effectiveness because of higher initial cost due to complex manufacturing process. And for the comparison, for the efficiency, Project A are not efficiency because of standard construction, simple construction and more piles need to achieve load bearing. But for the Project B, efficiency because of complex construction, faster and long lifespan. For conclusion, the choice of piles depend on the type of building, the type of soil and the load bearing of the project. Therefore, whether to use ordinary reinforced concrete or pre-stressed concrete span pile depend on the use and suitability of others because of each method or material has its advantage and disadvantage. That's all from our group. Thank you.